Hey everyone, welcome to my channel. I'm Satyam Tripathi and I'm a third year student at IIIT Vadodara. So today we're gonna be solving this problem removing digits, which is basically from the CSES problem set. Now looking at the problem statement, we are basically given an integer m, and on each step we may subtract one of the digits from the number. And we have to tell that how many minimum number of steps are required to make this number equal to 0. So as we can see that in this example test case, we have a number 27. Now let's say we pick out 7 out of this and we subtract 7 from 27, so we get 20. Now we pick out 2 from this 20 and we subtract that, so we get 18. Then in the similar way we take out 8 and we subtract that, we get 10. Then we subtract 1 from it, we get 9, and ultimately like 9 is a single digit number, so if I subtract 9 from 9 it will obviously give 0. So this is the problem statement. Now let's move towards its approach. So the approach is like pretty simple. Like let's say we have a number, let's say n, and it's of basically, let's say, 8 digits. So we know that like if it is of 8 digits, then obviously a is equals to log n base 10. So the number of digits will be basically equal to log of n base 10. This will give us the number of digits. So this is n. So for every digit that is present in n, we will subtract that from this number n. So for every digit we will subtract it, and so on for the rest. So in this way we will try to form it like to 0. Since we have to form 0, so I'll try to form this to 0. So basically in this we can clearly see that the recursive state is only dependent upon n. It doesn't depend like which digit I choose, and in each recursive state it doesn't depend on that. Therefore it is a one-dimensional DP problem, since each recursive state is dependent only upon n. So now let's move towards coding it. So now basically I'll be now coding the approach that we discussed earlier. So I'll basically first of all try with a recursive approach, a simple recursive approach without the DP optimization. Then I'll move towards that top-down approach, and then finally we'll explore the bottom-up approach. So first of all, let's take the input. So this is our input, and now let's code the function, recursive function. So it will take a parameter as n. Now we will only have a single base case, that is if n is equals to 0, we have to return 0. Now n can't go less than 0 in any way, because since take any like a number which has more than one digit, like 10 or like 20 or anything. So the maximum that we can subtract it from is 9, which is the greatest single digit number. So it will at max take you to a single digit number, and a single digit number contains that digit itself. So if you subtract it, it will give you 0. Therefore that n can never go 0. So there is only one base case. If n is equals to 0, then you have to return 0. Now moving forward, let's make the recursive function. So as we discussed earlier, we have to check each digit, and if it is not 0, we have to subtract it from this n, and we have to further recurse it. So let's extract each digit first of all. So while temp is not equal to 0, and take out the remainder, that is 10 modulo 10, right? Now if remainder is not equal to 0, we will recurse further. Wait a minute, we have to find the minimum number of ways, right? So let's take a minimum and initialize to a max value, right? And here we will be min is equals to mat dot min, and inside it, so min f of n minus 10, right? So finally I'll do 10 divided equals to 10, and at last we'll return min here. So function is complete, I think. Now we'll call it here. Wait a minute, I forgot like okay. So we basically print system out of print f of n. Okay, so I'm running this code. So this was our example test case 27. Now let's try 27. I think something is sorry. Okay. Let's do 27. So yeah, it's working. Now let's convert this into like optimize it to a top-down approach. So I'll make a DP array. Let's define it up. This is one. DP is equals to new int n plus 1, and let's initialize it to -1. So basically, in the recursion tree, as we could see here in the recursion tree, that the recursive state repeats itself. As we can say that let's say we had a number n. Now let's say we encountered, let's say 2. So here we will come to n minus 2, right? It can also be that let's say the number had let's say the number also had 1. So it can be we subtract this 1 from here and we get n minus 1. And again, let's say it contains integer, it contains a digit 1. So we can, let's say, further subtract it, and it will lead to the same same recursive state. So therefore we can see that it's a 1D DP solution. So since the DP only depends upon all the recursive state are unique because of only n, the digits doesn't affect their uniqueness. So we'll therefore use a single DP which is of size n plus 1. Now I'll pass this here and here also, and I'll check here if we have already calculated DP of n, then we have to return DP of n, right? Otherwise we'll store DP of n and return it. So what's the problem also? Right, what's the problem now? Again. Right, so we are ready, I think. So let's compile it. 7. It's giving 5. So still now let's convert this to a bottom-up approach, since we have explored a normal recursive solution and we have also explored a top-down approach. So now let's see how we'll code this bottom-up approach. So in a bottom approach, first of all, there will be we'll explore till 0, from 0 till first of all, wait a minute. First of all, we'll assign the basis. So DP of 0 is equals to 0. You all know that. Now for every number from I is equals to 1 till I is less than equal to n, I plus plus, we'll do the same thing that we did in this the top-down approach. We will traverse basically all the digits in that number. So for every I, while temp is not equal to 0, you can just copy it actually. Just copy and paste it here. Okay. Right, so we have to replace n with I. For every I we are calculating this, and here I'll have to change a little bit. Okay, so frame is not equal to 0. If frame is not equal to 0, we will like check if it will equal to, so we'll check deep, like main is equals to math.main comma dp of I minus whatever digit that we currently have ring. So this is what it will look like. I forgot one thing here, one plus. Okay, so here it is, and finally I'll assign this dpi is equals to 1. Okay, so this is also ready. Now let's try out how it's working. So system.out of printing. What we have to print? We have to print dp of n. Right. One thing more, I'll have to remove this. Yeah, we need to actually it can store. Okay, now so let's try this out. 27. Okay, that's okay. So let's try and submit this solution. I think so it is not. So language is Java, choose file. Yeah, where is my file? Here we submit it. So it's accepted. So we explored the top-down approach, we explored the bottom-up approach. So that's it for this video. If you like this video, then please drop a comment, and if you have any queries, you can just drop a comment and I'll try to reply as soon as possible. Thank you.